Yeah, I mean, I think what's helpful is, first of all, let's think about what are we talking about in innovation. I think one forgets that actually it's not a generic activity. It's a pretty complex series of steps. If we take, for instance, all the excitement that was created when we decoded the human genome, actually didn't come up with a single drug, because on itself, just looking at your genome doesn't tell you anything. Now I can take your genome and compare it to my genome, and we'll go down the list and say, there's some differences on there. I had mine done, and I'm 2% Neanderthal. I want you to know that. And I wouldn't want to speculate where I am, but you're going to see these differences, but that doesn't tell you anything unless you can actually say, okay, what other differences are there between us in terms of incidence of certain diseases. So now you have this massive big data exercise going on where we're trying to correlate all of this genetic data that we're starting to generate with all of the medical dossiers that are now being put online, and try to see if we can find, okay, if I have this anomaly, then I've got this disease. Now I also say, once I know the gene, but that doesn't tell me anything either, because actually whether disease is created or not depends on whether a protein gets created or not. So then you also have a communication between the gene and the protein, and I can interface with gene therapy at one end. I can go into microRNA on the communication, or I can attack the protein directly. All of that creates a target, and that's where the pharmaceutical industry starts, with all of that. So there's a huge amount of science going on really just to understand basic biology. And even there, as we come up with a target, you know, the NIH in an 18-month period generated close to 2,000 targets. It would cost you $75 million to validate each target. So there's going to be some risk capital in trying to figure out, well, which of these targets really makes the most sense to validate. And there are going to be some companies who are doing the validation, some companies who are starting to work on, I'm going to generate a molecule, and at some point someone's going to develop it. So, you know, what you see is that there is a tremendous interdependence, first of all. So all of these different actors have to decide, I'm good at this part of research, but I can't do what I do without everybody else. And some of that is going to be in academic institutions, some of it in universities, some of it in biotechs. And everybody has to say, I have this piece of it. Now, and this is why government is extremely important. The NIH does this. We have organizations like INSAM in France do this. We have a fabulous program here in Europe called the IMI program, which is creating collaborative research. It is driving this very collaboration that has not traditionally occurred in science. It's been very fragmented. And we're doing it on a European basis, because one of the other problems we have in Europe is, you know, we do research in Germany, and the Germans work with the Germans, or the Italians with the Italians, and so forth. You know, you can get Boston and San Francisco working together, but you got even difficulty getting Berlin and Munich working together. So all of these things are starting to, but governments will drive that. We have a project where we're trying to create research in Strasbourg between the research universities in the area, in Heidelberg, for example, in Strasbourg, co-funded by us and also the French government and the German government. So these are sort of some of the things where government clearly plays a role. The governor of Massachusetts put in $1 billion 5 years ago to really get biotech, even though it was a biotech metropolis. It said we're not being competitive enough. There isn't enough venture capital, and put $1 billion on the table. Was that personally or was the city? No, that was the state of Massachusetts. I'm just checking. So those kind of things happen in America, don't they? But so government can play a role in funding, in creating the right models. Education is fundamentally important. Those countries that have the most competitive universities will win, and clearly we can't have great education systems without government. They can play a role, obviously, in the regulation, and here this is a big issue, particularly as science evolves. Tom and I were talking before the break. You know, you can come up with some really breakthrough technology, but there's probably going to be a higher level of risk associated with that. So who actually is going to make the right risk-benefit call as to whether or not we should put this technology in place or not? That's going to be regulation. Today, I'd have to say in healthcare, we do not have a very good model for risk-benefit. So you're seeing a lot of research being driven into oncology and rare diseases because we don't have a really good system of trying to evaluate risk-benefit in other models. So all of this, I think, government is absolutely critical to us. In terms of socializing the risks, I'm not so sure that we actually have, because at each one of these steps, you are still having risk. You know, once you have a target, you still have an awful lot of risk that you're going to run into a safety problem or the drug isn't going to work. We've been working for 20 years on a dengue vaccine. I had to spend billions on this. We'll find out this summer, after 20 years, whether the thing works or not, even though, you know, the target was relatively well identified. So I'm not so sure we should be arguing about where the value is. I think we should be really saying this is a fundamental lever, particularly for Europe. We're not going to be a low-cost economic environment. We have excellent education systems traditionally. We've had our share of Nobel Prize winners. I think if we get the right way of working collaboratively together, Europe can be competitive and actually generate an awful lot of wealth, not only in terms of health, but also in exports.